Welcome everybody, it's Ramchandra from CIVIL-MECH-MATHS Concepts, and in this lecture I explain certain MCQs which I have prepared by myself, and from basics to deep understanding of fluid mechanics is explained here. And for writing a MCQ book for everybody, I have taken off for about more than a month, and from now onwards I will be releasing the regular videos. Please buy my book once it is released, maybe in a couple of months, in Amazon. That is MCQs for fluid mechanics. Welcome everybody, it's Ramchandra from CIVIL-MECH-MATHS Concepts. Today I am taking care of the latest MCQs from the basics to the advanced stage slowly. For this lecture and my previous lectures, there was a lot of gap. I am trying to write a textbook on fluid mechanics so that you can better understand the concepts with videos and you can solve the problems by seeing the textbook also. Maybe in a couple of months I will be releasing the textbook in Amazon in Kindle form and paper book form also. And while preparing the textbook, I had to go through different research papers and different literature I had to read, and I am preparing the textbook. For that, there is a delay in preparing this latest video. Now, I will be continuing the videos as regularly as possible, and these MCQs, they may look very simple, but they are very critical to understand and they are required to be understood well. Now, the first question is regarding density and viscosity of seawater and castor oil. Which of the following is correct? Please try to understand. Here, I am not only asking one property. Two properties are clubbed here, density and viscosity. With your general knowledge, please try to understand. Put some castor oil on top of water. Take it in a small cup. Take small water and a drop of castor oil you put there. Then you see that castor oil floats on the water. Seawater density is more than the ordinary water, because seawater will be having lot of minerals. And here what I am asking you, I am asking you to compare the densities. First let us talk about densities. To compare the densities. Then we will compare the viscosity. Sometimes our general knowledge works better in the MCQs. When you compare the density of castor oil with seawater, castor oil floats on seawater. Castor oil floats on seawater, which implies density of castor oil is less than seawater. That is our first observation. Now you see in the alternatives, both density and viscosity of castor oil are more than those of seawater. Here density of castor oil is less than seawater, that is our observation. Hence this option is wrong. Both density and viscosity of castor oil are less than those of the seawater. Let us see about the viscosity afterwards. This can be partially right. Density of castor oil is less than that of the seawater. For castor oil, density is less, yes, we agree, and viscosity is more. Let us see what about the viscosity. Between B and C we have to see. Then for castor oil, density is more, this is denied. Now between B and C we have to find the correct answer. As far as density is concerned, the castor oil density is less than that of seawater. Then what about the viscosity? Now you see, castor oil or any oils for that matter, even lubricants, they are used in machinery. Why they are used in machinery? Because of their viscosity. The viscosity, the resistance to flow. Viscosity is nothing but resistance to flow. That means oil sticks to your hand, whereas water doesn't stick to your hand. The reason being, water has very little resistance to flow, whereas castor oil has got very high resistance to flow. Hence, viscosity of castor oil is more than the viscosity of the seawater. Now, let us see. Answer B. Both density and viscosity of castor oil is less. That is a wrong answer. For castor oil, density is less. Agreed. Viscosity is more. Agreed. The reason being, when you take castor oil in your hand, it sticks to your hand. It shows that there is a resistance to flow. Whereas for water, it doesn't stick to your hand. Hence, when you compare with castor oil, it doesn't stick, it is less sticking to your hand. That means the viscosity of water is less. There is resistance to flow of water is less, whereas resistance to flow of castor oil is more. Hence, castor oil density is less, viscosity is more. That means castor oil floats on seawater and sticks more to hand. These are all general observations, but you could solve one problem in SSCJE. From the beginning I was telling, in staff selection or any UPSC examinations, your applicability of the engineering is more important rather than the theory. Please give importance to applications of engineering. I think you understood this concept, and as a homework, you just note down properties of some common fluids. Homework, note down rho and mu values for some common fluids. And as we discussed, similar way, you discuss on your own and find out why that particular value is more for a particular material, fluid, and why a particular value is less for a particular fluid. Compare your densities and viscosity. You need not remember the values, but try to understand the concept. Our next question is very good question. It's a very good question. The equation T2 by T1 is equal to P2 by P1 to the power of K minus 1 by K, where K is equal to specific heat constant, is applicable when the process involved by the fluid is. Instead of specific heat constant, we can write specific heat ratio. Please read it as specific heat ratio. That is Cp by Cv. That is equal to K. We can even say it as lambda. That also we can write. T2 by T1 is equal to, it's a very important equation. Please remember gamma, sorry, it's not lambda, gamma minus 1 by. This value for diatomic it is 1.40. Now, please try to understand in depth what this question says. This question says this particular equation is valid, is applicable when the process involved for the fluid, there are many types of processes are there for a fluid flow. On the process of fluid flow, many questions are asked in staff selection JEE examination, especially regarding the pressure variation with temperature as you go up in the altitude on earth from earth. That's also is like this. That question in 2024 it was asked. Now, it's not that same type of question will be asked. The question can be a twisting question and a deep question like this also. Ultimately, we have to understand what is the process. The process is controlled. The relation between temperature and pressure is controlled by this equation. T2 by T1 is equal to P2 by P1 to the power of gamma minus 1 by gamma. Now, I have asked it is valid when. Okay, you know the formula. Sometimes you need not by heart the formula also. If you just understand the formula and see and remember the formula, it's okay. You need not by heart. Formula is already given. And the question is where it is applicable. Applicability is more important. Please try to understand. Then you should know what is adiabatic and what is isentropic. Adiabatic is the process where there is no heat flow across the boundaries. There is no heat transfer across the boundaries. That means there is an insulation. This is one body A and body B. There is a boundary and it is insulated between A and B. Insulation is there. Then there is no heat transfer. For example, another body let me take, and it is put in an insulating container like this, and there is no heat transfer from this to atmosphere. Then this is also called as adiabatic process. That means when there is no heat transfer, then that process is called as adiabatic process. Now, what is isentropic process? Isentropic is entropy. Entropy is same. Entropy is same means there is no friction. Isentropic means no friction. There is no friction. Adiabatic means there is no heat flow. This equation is valid when it is both adiabatic and isentropic. That means there is no friction, there is no heat transfer. Then we can get these ideal equations. We have simulated a system wherein we have thought that there is no heat transfer and there is no friction also involved in the process. If friction involved in the process, what happens? Friction creates heat. That means heat should go on increasing because of the friction. Entropy goes on increasing. Iso means what? Iso means constant. That means entropy is constant. Entropy is constant means there is no friction. That means heat is not getting generated. Neither heat is transferred from one body to another, from one environment to another, and there is no heat increased automatically in a system. Then that system is called as adiabatic and isentropic. What I have given as the first answer? Adiabatic but not isentropic. No, the answer is wrong. Next, isentropic but not adiabatic. This is also wrong. Without heat transfer and with friction. Without heat transfer means indirectly I have told you in the third option it is adiabatic. And with friction means not isentropic. That means same A I have repeated in C, but A I have taken adiabatic as without heat transfer. I have expanded the meaning of it. I have expanded the meaning not isentropic, means friction is there, isentropic friction is not there. Please try to understand. Isentropic means friction is not there. But when it is not isentropic means friction is there. This is not isentropic. Please try to understand which friction means. The meanings of the words also can be combined in the examination. You should understand clearly about the meanings of the words. It's not only by hearting, you should understand. Next, with heat transfer. And without friction. With heat transfer and without friction. It is isentropic. With heat transfer means non-adiabatic. In this beautiful question, the answer is not given. A, B, C, D all are wrong, and the answer, this question is made by me. Only to make you aware the meanings, engineering meanings of the processes. It's not about your correct answer or wrong answer. The equation is applicable when process involved by the fluids is both, answer is both isentropic and adiabatic. Isentropic means no friction. Adiabatic means no heat transfer. Please try to understand this. The temperature and pressure and altitude questions are asked in a twisted manner in SSCJE. This question may little bit confusing to many people, but still try to understand what is its meaning. It should be both. Isentropic means there is no friction and adiabatic means no heat transfer. Then that equation we can easily apply. Now, the next question comes. The capillarity rise is given by the equation H. Usually what is the capillarity rise? You please tell me. You please try to remember your definitions of capillarity rise. Capillarity rise is given by the equation H is equal to 2 sigma cos theta by gamma r. R is the radius of the tube. A tube is kept. Like this, meniscus can be there. And this angle is theta, contact angle. And this is R, radius of the tube. If it is kept, let us say this, let us say glass tube. The capillarity rise is given by the equation H directly proportional to cos theta. Why I have given this? Because sigma, 2 sigma is constant. Surface tension is constant. Gamma is also constant. That is unit weight of the liquid. And radius of the glass is also constant. Let us say. Then H will be some constant into cos theta. That means H is directly proportional to cos theta. This is what I have derived from the equation. This is what I have thought and is universally accepted. The capillarity rise is given by the equation H directly proportional to cos theta. You need not remember the formula, but try to understand. Where H is the capillarity rise and theta is the angle of contact, which I have shown in the figure. then which of the following is correct? For mercury air glass interface, it's a very, very, very important interface. Usually we use the glass as the material for tube manufacturing and usually use mercury as the fluid. And when mercury as a fluid is used, glass as a tube, and air is there all around. Mercury air glass interface is there. What is the angle? The angle for mercury air glass interface, theta is equal to 130 degrees. Please remember this. This is a very important value. Please remember this. For glass and water interface, theta is equal to 0. For mercury air glass interface, theta is equal to 130. Here only you have solved your question. Theta is equal to 130 is nowhere it is there. For mercury air glass interface, theta is equal to 0. This is for glass and water, not for mercury. That means answer is none of the above. And for further theory, please read and view my YouTube channel. I am also bringing one book with MCQs. Maybe in couple of months I will be releasing it, because your examination in SSC JEE may be in the month of October or November. By that time I want to give YouTube channels and also books. These YouTube channels you can keep it as basis for understanding the subject, and the book, MCQs book, which I am going to release maybe in a month or two, that you can keep it as your reference. You can answer the questions. The standard of the questions will be like this in my MCQ book. Next, we will go to the question number 4. The vapor pressure is the pressure of the vapor exerted by gas vapor at a particular temperature. We can even say it as a saturated vapor pressure. The value of the saturated vapor pressure of a particular material is 20 degrees centigrade. Instead of material, we can say fluid. Material, we can say fluid or material or anything. At 20 degrees is 2.34 kPa. Usually, it is better always to remember the STP values, standard temperature and pressure values of different fluids. That's very, very important, because questions may directly involve certain constants at STP and NTP. Normal temperature and pressure, standard temperature and pressure. 20 degrees centigrade involves the STP, standard temperature. We will say it is a laboratory temperature or a temperature at which we regularly measure the values. The value of saturated pressure at 20 degrees for water, it is 2.34 kPa. Please remember this value. For water, that means indirectly with this value I am telling it is a fluid and it is equal to water. If you know this value, then you can easily understand what is it. What is that material? That's a fluid and that is water. Is water a Newtonian fluid? That is the question here. What I have asked, you know it is water. Then that material is a Newtonian fluid. Is it a Newtonian fluid? Is it a non-Newtonian fluid? Or is it not a fluid at all? This question is wrong, because we found that material as water and cannot be ascertained. This is also, we can say, partially wrong. Now we have to find between Newtonian and non-Newtonian fluids. For your information, water, air, they are Newtonian fluids. because they follow the Newton's law of viscosity. Tau is equal to mu into du by dy. This is what Newton equation. And water and air are Newtonian fluids. We just say water and air, these are the two important fluids. The questions on which can be asked by asking a saturated vapor pressure, melting temperature, boiling temperature, density of water. What is density of water by 1000 kg per cubic meter at STP. Then what is the density of air? That is equal to 1.204 kg per cubic meter. Please remember, the density of air is almost 900 times or 800 times lesser than that of water. Then for water and air, try to make a small table of their mu, that is dynamic viscosity, kinematic viscosity, density, and keep a table, and need not by heart the values, but at least you should know what is it. And your you can say specific volume, certain properties. Now, we just say by knowing this 2.34 kPa, we have found out that it's water and it's a standard temperature. Things cannot be asked at 45 degrees centigrade because you need not remember the values. At least STP values, you please try to understand. Next question. The main difference between a liquid and a solid when applied to a tangential force. I am applying a tangential force. There is a solid. I applied a tangential force here like this, and there is a liquid flowing, and I have applied a tangential force like this on top of the liquid surface. Then what is the difference between them? The force is directly proportional to strain angle. Please try to understand what is the strain angle. You should know. And directly proportional to strain rate. You should know what is the strain rate. The force is directly proportional to strain angle in liquids and directly proportional to strain rate in solids. Next, the force is indirectly proportional to strain angle in liquids and directly proportional to strain rate in solids. Third, the force is directly proportional to strain angle in solids and indirectly proportional to strain rate in solids. The answer D. The force is directly proportional to strain angle in solids and directly proportional to strain rate in liquids. Now, for example, let us try to understand the process of this tangential force effect. In a solid surface, like you take a rubber, just school student rubber, keep it on the hot table, and on top of it you put your hand and give a little push. What happens? The rubber bends like this. Do you agree? The rubber takes a new shape like this. The rubber takes this new shape. Do you agree? This angle is called as strain angle. Because it is a solid, you can measure the strain angle. As the force is more, the strain angle what happens? It increases. That means strain angle is directly proportional to the tangential force in case of solids. The force is directly proportional to strain angle in case of solids. Now, in case of liquids what happens? In case of liquids, whatever may be, remember the definition of liquids from my first lecture. whatever may be the smallest force you apply tangentially on a liquid surface, the liquid goes on moving, flowing, as long as that small force is applied, irrespective of the quantity of the force. That means strain angles cannot be formed here because the product is continuously flowing. Hence, strain angle concept is not applicable in case of liquids. Then what is applicable? Strain rate is applicable. Strain rate means strain is increasing with time. Strain rate, increase in strain with time. Strain rate is increase in strain with time. That is strain rate. That means strain rate is not applicable in case of solids, hence it is wrong. And strain angle is not applicable, strain rate is not applicable in solids, hence it is also wrong. The force is directly proportional to the strain angle in liquids. Strain angle is not applicable in liquids, hence it is wrong. Whereas the force is directly proportional to the strain angle in solids and directly proportional to the strain rate. As strain rate increases, the flow will increase. The force increases. As force increases, strain rate increases. That means the force is directly proportional to the strain angle in solids. Solids strain angle liquids strain rate. Please remember this concept. Remember this rubber example which I have given you, and this is both the diagrams you remember. Concept is clear now. Now let's go to the next question. The questions which I am going to give in the textbook, this is the jinx and sample which I am explaining to you. There may be very good examples and questions being given in the textbook which I am going to publish in Amazon shortly. From the Newton's law of viscosity for a particular case, you please see, tau is equal to mu into du by dy. The units of du by dy are per second. What is du by dy? Du by dy is equal to, it is change in velocity, that means dimensions will not change, meters per second. Change in distance, that is also dimensions will not change, meters, that means meters will cancel, then it is 1 by second, that is equal second to the power of minus 1. Now, can we write the same in terms of delta theta by delta t? I have shown you in case of rubber example, the original rubber is like this, and after application of some tangential force, this made an angle theta. That is delta in a time of t. Does theta has any dimensions? And what are the dimensions of delta theta by delta t? They are also per second. Degrees or radians, whatever you call, radians per second, degrees per second. But mainly we can approximate du by dy with delta theta by delta t. Here, the angle delta theta and delta t are respectively. Can it be any angle? And time, can it be any duration? Can it be infinity? Can it be 100 hours? Can you go on applying for 100 hours the pressure on a rubber which I have given you? You can apply the pressure for a very short duration and for a very short angle. That means small angle, the deflection can be very small angle. If you take material like steel, the deflection can be very small. When you take rubber, the deflection may be very larger when compared with steel, depending upon the crystalline structure of the material concerned. Now, small angle is accepted. It can be for a small angle. But is it for any time duration? That is the question mark. This question I am leaving it to you as a homework. Please do it as a homework. This is the question which I have made on my own to test your knowledge. Homework. Answer it. Small angle is accepted. You find out whether it is C or D. Which one is correct? Small angle is okay. Is it for a small duration or is it for any time duration? Please see the textbooks and try to understand and answer this question. Now, because sometimes I feel that a question out of some 10 questions should be left for your thinking process, sharpening your thinking process. Next comes the entrance length in case of a flow through pipes along the axial length of the pipe is. Here I have used axial length and flow through pipes. I have in the first lecture itself I have explained what is the flow through pipes. It's very important and it's a common example. The water distribution, gas distribution companies, water distribution companies, chemical distribution facilities in the plants and general water distribution, everything is dependent on pipes. Now, there is a pipe. Let me say, and fluid is flowing inside the pipe. The pipe is of, let us say, circular or it can be a rectangular also, depends upon the requirements. What is the axial length? Please try to understand. What is axial length? Movement along the axis is called as axial length. Measurement along the axis. What is the radial length? When you measure the length along the radius, this is radial length. Please try to understand. Axial length and radial length. Now, the entrance length in case of a flow through pipes. There is an entrance. You sent the fluid inside the pipe and the fluid goes inside the pipe and it flows in the pipeline. Now, this is the entrance point. Point A is the entrance point. This is the entrance point. The entrance length, there is one term called as entrance length. You please remember this. Entrance length is very, very, very important. Very important concept in fluid mechanics. The entrance length in case of a fluid, this is denoted by LE. Entrance length. Total length is L. I am not talking about the total length. LE I am talking about. Entrance length. The entrance length LE in case of a flow through pipes along the axial length of a pipe is the length from the entrance to a point where the transition from laminar to turbulent flow takes place. What happens in a pipeline? Let us say initially there is a laminar flow like laminates. Then there is a turbulent flow in the pipeline. The length from entrance to a point where the transition from laminar to turbulent. This is laminar. This is laminar. This is transition. This is turbulent. The process is like this. From laminar to turbulent, there is a transition. Afterwards turbulent and afterwards it goes on. The length from entrance to a point where the transition from laminar to turbulent flow takes place. This is the transition point. Is it LE? First alternative. Second alternative, the length of the transition zone. This is the transition zone when it is transforming from laminar to turbulent. Is it LE? Third, the length from entrance to a point which is equal to perimeter of the entrance. For example, I am using different types of entrance openings. Is perimeter, pi d is the perimeter for a circular opening, 2 into L plus B is for a rectangular opening, for a square opening 4 into A for a square opening. Is it the perimeter, up to the perimeter, irrespective of the flow, or D, none of the above? Very important question. Please try to read something about entrance length. It's not a simple question, it's a very complicated question. Entrance length is the length when the flow is fully developed. Please try to remember this sentence. When the flow is fully developed, that means when a flow starts inside a pipeline, the flow will not be fully developed like this. I have told you many times in many lectures previously. The pattern will be like this, then it will be like this, then it goes like this, parabolic, and this is the length fully developed. That means when the distribution pattern becomes regular and then the flow is fully developed, the length from the entrance to the place where the flow is fully developed, that length is called as LE. So answer is none of the above. Next question we will go. If the pressure distribution plot along the axial length of a pipe flow is available. Now, water is flowing in a pipeline. The pressure distribution may not be same at the entrance to the till end. There will be pressure distribution along the length. Let me say, from the conservation of energy principle, total energy curves which I have explained you in my previous classes, the pressure distribution can be like this, may not be to scale. This is length L, this is the pipeline, this is the length L. The pressure distribution curve is like this. If the pressure distribution plot, let me say, it may not be straight like this, it can be, because there will not be any straight flow in any practicals. It can be like this, pressure distribution. Pressure distribution is like this. If the pressure distribution plot along the axial length of a pipe flow is available, this graph is given to you. From that, we can deduce the following. What we can find out from this? What we can find out from this? Can we find out the velocity gradient? Because there is no velocity graph, hence we can't find out velocity gradients. Both B and C, it is also wrong. Now 2 we have eliminated. Now, can we find out the pressure gradient? You see, any gradient, I have already explained in my previous lectures, any gradient is nothing but change in value of some value, I can say pressure divided by change in distance. Now, can we exactly find out the pressure gradient here? we can't find out the pressure gradient because the pressure gradient here is having the slope of this PR pressure by L. P by L is equal to slope of this graph, pressure distribution graph. This is like this here, this is like this here, this is like this here, this is like this here. That means exact pressure gradient we can't find. Slope is equal to nothing but pressure gradient. The slope of pressure distribution graph versus pressure versus axial length is the pressure gradient of that particular pressure distribution curve of that fluid flow. That pressure gradient, if it is changing often in the graph, if it is not uniform, you cannot finalize the pressure gradient one value. Hence, getting the pressure gradient from this graph is not fully possible. Maybe partially. We are not asking for partial answers here. Now, when we find out the entrance length, that's where is the question. The entrance length can be found out from when the flow gets fully developed. What happens here? Flow is not fully developed. Please see. Here, flow not developed fully. But here, the gradient slope is constant. Slope is constant. That means slope of the graph is equal to constant. That implies fully developed. If the pressure gradient is constant in a graph, then we can say that pressure distribution versus axial length graph, if pressure gradient is constant, then we can say that this is fully developed, and the distance, the length at which the flow is fully developed, that distance is called as LA. That means entrance length LA means dou P by dou X is equal to constant. That is equal to for fully developed flow. You please remember this. Now, answer is A. Next comes, today this is the last question. I am giving these examples to you so that you will understand the concepts very clearly and you will understand the scope of my book, what I am releasing maybe in a month or two for the benefit of all. If the Reynolds number is 1345, what is Reynolds number? Reynolds number is equal to rho Vd by mu. I have explained very well what is Reynolds number and what is velocity, what type of velocity uptake in the Reynolds number. Very well in my first, second, third lectures. Okay. Now, this Reynolds number is 1345 given. What is the importance of Reynolds number? If Reynolds number is less than 2000, the flow is laminar. If Reynolds number is more than 2000, transition or turbulent, you can give some value for the transition up to 2500, 2700, then it will go to turbulent. Now, here what is the Reynolds number given? 1345. That means the flow is laminar. For a fully developed laminar flow, the value of LE, entrance length by diameter, is equal to 0.07 RE. Therefore, LE, what it is asked? Entrance ratio of entrance length to diameter. This is very, very important ratio, LE by D. That is equal to 0.07 into 1345, that is approximately equal to 91. The value of 91 is not there, hence none of the above is correct. Please, it's a very simple formula, 0.07 RE. Once you know the Reynolds number, from that you can find out whether the flow is laminar or turbulent. For the fully developed laminar flow, it is 0.07 RE and LE by D is equal to 91. This is what we should know, LE by D values. And these whatever small concepts are there, they are very well covered in Modi and Seth, Hydraulics, Fluid Mechanics by Modi and Seth book. It's an excellent book, please read it. And with this, I want to conclude the session of MCQs in Fluid Mechanics, and in the next session I will be doing some numericals on pressure measurement, because this fluid mechanics is fully concerned with pressure and velocity. If you can perfectly do your pressure calculations and velocity calculations, it's either a pressure distribution or a velocity distribution which is going to govern this fluid mechanics. If you can do or get perfection in pressure calculations and velocity calculations, I feel you can do better and understand the fluid mechanics very easily, and you can do better. In the next class we will do, maybe very early I will do second class, another class, because I don't want to delay due to some this notes preparation for the textbook release on fluid mechanics, that MCQs. Rather, it's not a textbook, it's an MCQ, collection of MCQs or preparation of MCQs by me. Personally, I took time, and the next lecture will be maybe either tomorrow or by day after tomorrow. Please review my lectures, please understand the concepts of fluid mechanics, which may not be given in any textbook. It is out of my understanding and interest towards the subject. I am giving these lectures. Please try to take advantage of these. Try to score high in your examinations. Let it be GATE examination 2026 or UPSC examination or your SSCJE examination. Best of luck to everybody. It's Ramchandra here again, an IIT alumni from CIVIL-MECH-MATHS Concepts channel. Please see my other videos, review them, comment on them, and advise me if you want anything more on the subject. And I am going to release a MCQs book on Amazon in KDP and in paper edition and also in Kindle edition, ebook edition. Please try to read that, take a copy of it and keep it with you. And these videos you can view them as references for understanding the subject in a better manner, so that you can do better in your examination. It's not only my efforts will work, your efforts for understanding and going through different reference books and understanding the subject and doing better in the examination. Best of luck to everybody. Thanks a lot for listening to me. I will come up in a day or two with another lecture with numericals on pressure measurement. Numericals on pressure measurement, very important topic. Thank you. Best of luck to everybody.